Hurricane Projects, Casey Brown, Leah Lavoie, Stephanie Cogswell, and Victoria Nixon. A hurricane is defined as a large swirling storm with wind speeds of at least 74 miles per hour. Hurricanes first start as a tropical disturbance, then can develop to a tropical depression if the wind speeds get to be 38 miles per hour. If the winds in the tropical depression reach winds of 39 miles per hour, it will then be classified as a tropical storm. The tropical storm will change over to a hurricane if the winds become 74 miles per hour or more. Within a hurricane, there are 5 different categories it can be placed in. Which category the hurricane is placed in is determined by the hurricane's wind speed. There are 3 different parts of a hurricane. The eye is the center of the storm. At the eye, winds are light and skies are often partly cloudy, or even clear. The eye wall is a ring of thunderstorms that swirl around the eye. This is where winds are the strongest and rains are the heaviest. Then there are the rain bands. These are bands of clouds and rain that go far out from the eye.
Tropical cyclones that form over the Atlantic Ocean or Eastern Pacific Ocean are called hurricanes. Tropical cyclones are like giant engines that use warm, moist air as fuel. The air rises upward from near the surface, and higher air pressure pushes into these low-pressure areas. That new air becomes warm and moist, and it continues to rise and swirl. As the air cools off, the water in the air forms clouds. The whole system of clouds and wind spins and grows, fed by the ocean's heat and water evaporating from the surface. Here's a diagram to show exactly what happens. The waters of the Pacific Ocean rarely go higher than the low 70-degree point, contrary to the Atlantic waters reaching 80 degrees, which helps maintain the hurricane's strength and intensity. Hurricanes surrounding the U.S. tend to move northwest, meaning Pacific Ocean hurricanes go offshore rather than hitting the mainland.
Temperature is an important factor for the storm to be able to develop into a hurricane. The water must be 80 degrees in the given area for the storm to develop into a hurricane. This is because the water that is evaporating from the ocean needs an energy source, which would be the warm water temperatures. Another factor is wind flow. Hurricanes travel from west to east. If they don't travel in an easterly direction, they do not move. If they don't move, they are not considered a tropical storm and instead are just a thunderstorm. The last factor is the rotation or spin of the storm. Before the storm can officially be considered a hurricane, there must be a rotation or spin.
From 1970 to 2004, researchers looked at 4 factors that are known to affect hurricane intensity. These were humidity in the troposphere, wind, large-scale air circulation, and rising sea temperatures. Of these factors, only rising sea temperatures were found to influence hurricane intensity in a statistically significant way over a long-term basis. The other factors affected the hurricane on a relatively short-term basis. Once formed, hurricanes took on energy from the warm water to become stronger. A storm will strengthen if there is a supply of warm water, moist air to feed it. Warm, moist air is found above warm tropical ocean waters. While a hurricane is over warm water, it will continue to grow. It dies down once it moves away from the tropics into cooler ocean air, and it weakens as it travels over land.
In a hurricane, the low-pressure center is the eye of the storm. The stronger the pressure difference at the ocean surface, the higher the wind speed. Moisture from the warm water converts to heat in the thunderstorms that spiral into bands of rain that form around the eye. As air is forced into the eye, it rises rapidly and condenses, releasing large amounts of heat into the atmosphere. This refuels the hurricane, and the lower the pressure at the center of the storm, the stronger the hurricane. An example of this happening was when Hurricane Harvey went from a Category 3 hurricane to a Category 4. Before Harvey hit land, it passed over a warm body of water. This lowered the atmospheric pressure, thus strengthening the hurricane. Hurricanes, cyclones, and typhoons are all scientifically classified as a cyclone. However, they get their names by where they form. Cyclones form in the Indian Ocean and off the coast of Australia. Typhoons form north of the equator in the western Pacific Ocean, and hurricanes form in the Atlantic and eastern Pacific Oceans.
Category 1 hurricanes has winds up to 74 to 95 miles per hour. It is faster than your average cheetah. Category 2 hurricanes has winds up to 96 to 110 miles per hour. It is faster than the most average pitcher. Category 3 hurricanes has winds up to 111 to 129 miles per hour. It is close to the speed of average pro tennis players. Category 4 hurricanes has winds up to 130 to 156 miles per hour. It is faster than the world's fastest roller coaster. Category 5 hurricane has winds up to 157 miles per hour. It is close to the average speed of some high-speed trains.
This is a graph showing the number of hurricanes per decade the past 100 years. The most was 24 hurricanes. This occurred from the years 1941 to 1950. The least was 9 hurricanes, occurring from 2001 to 2004.
What is the relationship between temperature of ocean water and the strength of a hurricane? According to mass.pbslearningmedia.org, hurricanes use warm water in order to release high temperatures into the upper atmosphere. This results in winds that spiral. Any increase in the heat of an ocean water will increase the strength of a hurricane.
Irma became monster storms while swirling over 2 separate stretches of unusually warm ocean water. Peter J. Webster, an atmospheric scientist at Georgia Institute of Technology, said it's clear that Harvey intensified amid some abnormally warm waters in the Gulf of Mexico, and that Irma followed during a season the Atlantic was also warmer than average. Another crucial influence is wind shear, which describes the change in speed and direction of winds according to altitude. Typically, low wind shear conditions increase the storm strength. With weak wind shear prevailing in the Atlantic, Irma was able to rapidly gain strength and maintain it. Another factor now in play in the Caribbean is the influence that one hurricane will have on another that follows closely behind its heels.
Climate change does impact the hurricane. With warming temperatures, scientists have seen an increase in not just the amount of storms, but a jump in major storms. High temperatures feed the storms. In Houston, the amount of rainfall that was recorded would have been considered rare, but with the increasing temperatures, causes it to be less rare. These warm temperatures and warm air holds more water vapor, and the results are what we saw in Hurricane Harvey. Harvey had 2 high-pressure systems surrounding it, which locked the storm in place.